So friends, welcome you all. So in this video, we are going to discuss all algebraic laws related to regular expression. So first I will tell you why we use these algebraic laws. So sometimes we have complex regular expression for some set of strings, and that can be without changing its meaning or without changing its language, it can be simplified. So to simplify complex regular expressions, we need algebraic laws. So there are six laws related to regular expressions, and that all these laws we will discuss one by one. So these six laws are there, and we will discuss all these laws one by one. So let's start with the identity law. So friends, identity law basically relates any regular expression with empty set. Empty set means phi. So if one regular expression is R, then its union with phi will be equal to R itself. Will be equal to R itself. And its concatenation with phi, its concatenation with phi will provide you phi. So that this there is choice. So R plus phi gives R, but R dot pi concatenation of R, any regular expression R with phi is phi itself, because if we have nothing in one set, so we will get nothing as a result. So this would be phi. So this is identity law. This is identity law. Now we will discuss another law, idempotent law. So idempotent law provides combination of one regular expression with itself. So you can see here R plus R will be equal to R itself, because we have two choices here. Even we can select R, or another choice is again R. So any of the choice we select, we will get R as result. Now this law holds for union, but it doesn't hold for concatenation. It doesn't hold for concatenation. So this is not equal to R. So this law, idempotent law, is not true for concatenation operation. So now third law is commutative law. So third law is commutative law. So commutative law basically relates to regular expressions. So it is it is true for union operation only. It is true for union operation only. How you can see here. So if R and S, two regular expressions are there, then if we write R plus S, that will be equal to S plus R, because on both the side we have two choices. Either we can select R or we can select S. Here also either we can select S or we can select R. So these two would be equal, but it doesn't hold for concatenation operation. It doesn't hold for concatenation operation, as R dot S is not equal to S dot R. So this doesn't hold for concatenation operation. Similarly, this as we discussed the idempotent law just before this, so it was also true for union operation only. Friends, now we will see associative law. So how associative law is there? So you can see here, like suppose R, S, and T, three regular expressions are there, then we can relate them with associative law as, for union, we can write as R plus S plus T equals to R plus S plus T. So in both the cases, we have three choices. Either we can select R or we can select T, S or we can select T. So here also we can select R or S or T. So these two are equal. That means associative law is true for union operation. Let's see whether it is true for concatenation operation. If the concatenation of R and S is concatenated with T, then it must be equal to concatenation of S and T, that is uh, concatenated with R. So this holds true for concatenation operation also. As you can see here, the sequence would be RST, and here also the sequence would be RST. So this associative law holds true for both union and concatenation operation. So now we will see distributive law. Distributive law. So you can see, my friend, how we can use distributive law with the union and concatenation. So if I am writing R plus, again we are considering R, S and T are three regular expressions. So R plus S is concatenated with a T, then it would be equal to R dot T union S dot T. S dot T. And this would be equal, both will be equal. So this holds true for distributive law, holds true. Now again in some different way, if we apply this, like R dot S plus T. Now we are concatenating R with the union of S and T. So it would be equal to R dot S plus R dot T. So this holds true for this also. So distributive law is applicable to regular expressions in this way. Now the last law is Kleene closure law, or you can also call this as Kleene star law. Kleene star law. You can also call as Kleene star law. So both are same. Now we will see how Kleene star law applies to regular expression. So now if we have one regular expression there, R, and we have already seen in some previous videos that R dot R star is equal to R plus. R dot is R star, or you can say R dot and Kleene closure of R equal to positive closure of R. And now if we union it with epsilon, R plus is plus union positive closure of R union epsilon, then it would again give us R star, or Kleene closure of R. Kleene closure of R. So that means in other way we can write epsilon plus R dot R star is equal to again R star. So this is one of the Kleene star law or Kleene closure law. Now one more law is there, like if we take Kleene closure of R and again we take one more Kleene closure of R, then it would be equal to Kleene closure of R itself. Now if we take Kleene closure of epsilon, Kleene closure of epsilon, then it would always be equal to epsilon only. Then it would always be equal to epsilon only. So similarly, if we take union of epsilon and Kleene closure of R, then it will again give us as Kleene closure of R. So these four laws are related to Kleene star law. These four laws are related to Kleene star law, and these four laws. you can consider as Kleene star law. So I hope, friends, all these algebraic laws would be very much clear to all of you, and we can use them if required. So that's why it is very necessary to all of you to know these laws. So I hope these would be very much clear. And if you have any doubt, you can always write to me in comments, and I will definitely reply your comments. Thank you. Thank you so much.